Hello, I'm Grant Beckman. I'm an engineer with the U.S. Ice Drilling Program. I'm part of a team that designs, builds, and operates ice coring systems. These systems are sent usually to Greenland and Antarctica, and because it's such a big process to get the drill there, it's critical that the drill is taken apart and packaged very carefully, as well as with clear instructions, so that it's easy for us to assemble it in the field when our fingers are cold and the wind is blowing in our face. The drills generally follow a tethered design, meaning the drill itself, the part that collects the core sample, is attached to the end of a cable. And that cable runs over the top of a tower, and that's how we lift and lower the drill into the glacier. So the challenge today is to have your students design a ice core system that also solves some of the challenges that we encounter in real life.
Well, thanks, Grant, for that introduction. We here at the Ice Drilling Program have taken Grant's real-life challenges in Antarctica and turned it into an engineering design challenge for your students in your classroom. With any engineering design challenge, the goal is to get the students involved in the complete engineering design cycle, where they're building, testing, improving on their design, and then eventually coming up with a final product. Our challenge has 5 distinct parts. In the first part of the challenge, the students are to design their own drilling rig to retrieve ice cores. With any engineering project, it's important to give the students constraints. One of our constraints is the students are challenged to only use the materials provided. We have a carabiner to act as a pulley. We have a super strong magnet that can act as an ice collar to retrieve the ice core. Our ice core is going to be a black metal pipe. We have bamboo skewers that are going to act as construction beams, and we have Sub-Zero putty, connector putty, that looks a lot like Tootsie Rolls. And we have a little string to act as cabling. So the first part of the challenge is to have your students break into teams and successfully build a drilling rig that can be pulled across the ice and retrieve an ice core. Here you can see testing of our initial design. I'm using a table with a little hole in the middle where I can drop the ice core lifting collar through. As the project is designed, we thought just pulling 2 tables close to each other would work, so you can pull your drill rig along the top and then drop down between the tables to actually retrieve the ice core. As you can see, that first iteration didn't work too well, so here we go through the design process trying to improve it, build a second design, maybe better, more stable than the first one, that could actually retrieve that ice core. That first iteration you saw worked fine as far as it was a portable drill rig, but as far as retrieving the ice core, that didn't work out too well. So here we go. Trial number 2, back to the testing. And that iteration does work. Now that we have a design that we like, it's time to move on to part 2, where we create a detailed parts list and write our own assembly instructions. The handouts come with a budget sheet. You can compare how much each team's project costs, and each team then needs to write their own set of detailed instructions that another team can use to put their drill rig together. This then models how teams in Wisconsin actually design the drill rigs, and teams in Antarctica need to actually put them together and use them. Now that we have a design we like and instructions, it's time to pack up our kit. You pack up all the parts, the instructions, and then teams will swap with each other and try to build the other team's drill rig. We hope you and your students will enjoy this engineering design challenge. It's just one of many activities available at icedrill-education.org. Thanks again to the National Science Foundation and the U.S. Ice Drilling Program for supporting these types of activities for your classrooms.